All right, so we just covered shims and stubs and mock objects. We kind of have a big list that we're starting to grow, don't we?
We do.
Next, we're going to talk about dependency injection. Do you want to talk about that, Steve?
I would love to. One of my favorite things when we start jumping into unit testing frameworks is dependency injection. So we've gone through some things that are mocks and stubs and fakes and shims, that whole concept. There's so much confusion and overlap in how people define that out in the world. And in reality, you probably aren't going to cut those definitions into pieces so tightly. I mean, if you even just look at mock, they just dump them all together in one, right? Your stubs and they're all just one, at least your stubs and mocks. Dependency injection, on the other hand, is a really clean concept. And it's a complicated one, but it's an architectural pattern that lets us now inject components that are easily testable into our applications. And I want to do that with two things. One, walking through what a dependency injection framework basically is, and then coming back and looking at a very quick example of what one looks like. So dependency injection. It's a software design pattern that allows the removal of hard-coded dependencies and makes it possible to change them whether at runtime or compile time. So why dependency injection? There's a lot of reasons. It makes your code more testable because it makes it loosely coupled. It takes away some of the really tight coupling that you very often get when you compose multiple objects in any object-oriented language. So for instance, you may have a dependency on a logger. I'm going to come back to logger, right? And you have a dependency on a logger. And if that logger is the one you use, and you have some other application that needs a logger, in the constructor of your class that uses the logger, you may create the logger in that class. Now the problem is next time when you create this upper level class and you want to test something in it, that logger is the logger that's writing to the file system. But what if you want to swap it out with a different logger, like one that's a mock object that writes to nothing or just keeps a little bit of state so you can query against it? That's the difficulty we run into. And all of a sudden, because we have this hierarchy or this composition of objects, it becomes difficult for us to test those applications. So dependency injection takes those dependencies and actually inverts them, inversion of control, so that we're creating this object, but then we're passing in what we want to be this logger. So we can pass in the mock object, we can pass in anything we like. We'll get to that in just a moment, but let's take a look at some of the other benefits first. It allows us to do late binding. What that means is we don't have to bind the particular logger to our class early. We can wait and bind it potentially even at runtime. It makes our code far more maintainable in the long run. When you first look at code that's using a dependency injection framework, your brain goes boop. And after that, you kind of get used to it, and you really have to get in there and use one. I'd actually recommend building one, but I'll get there in just a moment. It allows you to reconfigure things without recompilation. A lot of times you can go in, make a couple changes, and save it, and maybe restart your app if everything's in memory, who knows. But you'll be able to pick up those changes and run a different configuration of your app without recompiling. This isn't TDD or unit testing. This would just be you're logging to a database now, and now you want to log to a web service somewhere. And it can help you make your legacy code easier to test. One of the big things with legacy code is that you often have not high cohesion and loose coupling, but low cohesion and high coupling. And dependency injection frameworks break high coupling. That's the first thing they do. They allow you to get that loose coupling, which is really critical.
Yeah, and I think that's a great point to bring up, that you really can use dependency injection for legacy code. If you're struggling to figure out how do I actually test my legacy code, look into dependency injection.
Yeah, exactly. I think it's a great idea. In fact, we're going to come back to that in our legacy code piece, but just briefly, because we're mentioning it here. So there's a lot of dependency injection frameworks. Now, I've just listed a few in the .NET world. There's plenty in the Java world. There's plenty in the C++. There's plenty everywhere. But in the .NET world, some of the main ones are Unity, Ninject. I kind of like that name, Ninject. Castle Windsor, which has been around for ages. Autofax, a popular one. Structure Map. Spring.NET comes from Spring, which was the Java-based version of that. And then I want to point out specifically a couple. Scott Hanselman has a great list for this down here at the bottom. But above that, a guy named Ayande Raheen has a blog post. It's from a long time ago, but it's building an IOC container. That's the inversion of control container, which is the same thing as a dependency injection container in 15 lines of code. And here's where I recommend you click on that so that you can build your own dependency injection framework. Are you going to use that dependency injection framework in production? No. But it gives you a really clear idea of how they work. Now, I want to stop just before we wrap this up into a demo. I want to talk a couple different ways you do dependency injection. First, when you create an object, it's called constructor injection. And if you start an object and you're newing it up and you go into the constructor, oftentimes you'll pass in a parameter, like for instance, what logger you want. So you say, I want this particular logger when I create my class, my foo class. This is the logger I want. The nice thing is then when you construct it inside your unit test, you just pass in your stub logger or your mock logger, and away you go. It's really, really easy in the constructor. But if you're working with code that has a massive amount of child objects that it maintains within it, that means your constructor can get really, really long, and you get some complexity there. So another common way is property-based injection. So what that means is what you do is you have your class, which by default creates its own normal logger, just the logger to the file system or whatever, but it exposes a property so that you can set it and swap out that logger at runtime. So it creates a new one, and then you swap it out before you run it. That tends to have less of an impact on your code in terms of like a massive amount of refactoring. You're just adding methods or adding properties, and that can help support your testing. There's also method-based injection, and then there's injection that the dependency frameworks use, which is a configuration-based injection. And that's what we'll be seeing here in the next demo.